I'm going to explain Kirchhoff's current law in this video. This right here is Gustav Kirchhoff. He was a German physicist, and in the 1840s he came up with two laws. Unsurprisingly, they're called Kirchhoff's laws. His work followed George Ohm's work and is now at the core of electric circuit theory as we know it. The basic principle on which these laws are based is the conservation of electric charge. Charge can neither be created nor destroyed. Let's assume we have a current that flows through this wire. Here's a point A. The current can now flow in two directions. Let's say the current I1 can flow through two directions. It flows out as I2 and I3. Because charge is conserved, the current that enters A, I1, should be equal to the sum of the currents that leave A. That's I2 plus I3. This point A, where the currents leave and enter, is called the node or the junction. This law is therefore sometimes referred to as the node law or the junction law. The sum of the currents entering a node, in this case I1, is equal to the sum of the currents leaving the node, in this case I2 plus I3. Let's show a simple example. Let's say we have a voltage source and we have a current, let's call it I1. It enters this point here, that's A. It can now flow in this direction, let's call this I2, and in this direction, let's call this I3. If we apply Kirchhoff's current law, KCL, at node A, if we apply KCL, the current that enters is I1, the currents that leave are I2 and I3. So according to KCL, the current that enters, I1, is equal to the sum of the currents that leave, I2 plus I3. Let's assume that I1 is 10 ampere, I2 is 4 ampere. What is I3? We know that I1 is equal to I2 plus I3. 10 ampere is equal to 4 ampere plus I3. I3 is then equal to 6 ampere. Let's move on to another example. Let's say we have a voltage source and we have a current that flows here. So let's call this I1. It enters the node, let's call it A. And then at this point, there's two resistances. These resistances are in parallel. Let's call them R1 and R2. We now want to find the currents that flow through R1 and R2. Let's call them I R1 and I R2. So at this point, let's call this node B. We have a current that enters. If this is I2, the current that enters here is I3. And this I3 right here at node B is equal to IR1 and IR2. The sum of IR1 and IR2 is equal to I3. We just applied Kirchhoff's current law at point B. We know that these resistances, let's say R1 is 2 ohms and R2 is 4 ohms. They are in parallel. According to Ohm's law, we have V is equal to IR. We also know that if resistances are in parallel, the voltage across the two resistances are the same. From the previous example, let's say we have I1 is 10 ampere, I2 is 4 ampere. Applying Kirchhoff's current law at A, we have I3 is I1 minus I2, which is 6 ampere. Now, I3, which is 6 ampere, is equal to IR1 plus IR2. Since the voltages are the same, the resistances are in parallel, we have V1 or VR1 is equal to VR2. IR1 times R1 is equal to IR2 times R2. R1 is 2 ohms and R2 is 4 ohms. IR1 is then 2 times IR2. Now, plugging into this equation, we have I3 is equal to 2 times IR2 plus IR2, which is 3 times IR2. Since I3 is 6 amps, we have 6 amps is 3 IR2, or IR2 is 2 amperes. IR1 is 2 times IR2, which is 4 amperes. So now we get IR1 is 4 amperes and IR2 is 2 amperes. In this node B, the 6 amperes splits into 2 amperes and 4 amperes. With this, we come to a conclusion of an explanation of Kirchhoff's current law.